value, if I have any right triangle, and let's say I have a value of 50 degrees here, and I only give you one side length. So if I side with trig ratio, sine, cosine, or tangent, we're able to find any other side length. So the advantage of trig is now giving anything in a triangle, as long as I have one acute angle, because remember, trig ratios only work in right triangles. I only need one value. Once I have that value and a side length, I can find anything else. Now, of course, I know that's going to be 40. And then if I say I want to find this side length, then I would use the tangent of 50 is 8 over x. And in this case, if you want, some people like to set up a proportion, and 8 is tan of 50 times x, and that's when I would divide by tan of 50. So whatever 8 divided by the tan of 50 is, and you have to make sure you are in the right mode. All right, so 8 divided by tan of 50 is 6.7. So this is 6.7. Now I have the option, of course, I could use sine and do sine of 50 is 8 over y, and I could find y. I also have the option to then use Pythagorean theorem, and I could do 8 squared plus 6.7 squared equals y squared. So as you can see, it just kind of all plays together. It's kind of neat that trig helps us find those ratios. The other thing I hope the video helped you explain is that the value of this 50 degrees is the same in every single triangle. Now, when you have the value of 50, there's only one single ratio that allows us to find this side. So when we found the side at 6.7, that is, if this is 50 degrees, the ratio, if that's 8, like it's always going to be 6.7. So it's just that there's a ratio that always goes with those values. And here's the thing. If I later give you the ratio, the tangent of 8 over 6.7, you're going to be able to tell me, if that's what the ratio is, you're going to be able to tell me that that is a 50-degree angle. And we'll talk about that later. All right, so the last thing I wanted you to do is be able to look at and find the exact values of what this is. So when I ask you for the sine of 45, I am asking you for the exact value. So one thing I want you to realize is I don't have to give you a picture. I can say, what is the exact value of the sine of 45? So here you would have to draw your one, and the square root of 2. When you draw your 369, you have to realize that 1 is always on the short leg, root 3 is opposite, and 2. So when I say sine of 45, sine of 45 is 1 over 2. Well, guess what? Can't leave a radical. So root 2 over 2 becomes 2 over 2. And that's exact. Now, if I want, I can take the square root of 2 and divide it by 2, and I get 0.7. That's what the ratio would be. And if in a calculator you type in the sine of 45, that's where you'll get 0.7. But normally, I'm not going to ask for the 0.7. I'm asking for what the exact value is. Cosine of 45 is also 1 over root 2, so that's root 2 over 2. Tangent of 45 is going to be opposite over adjacent, and adjacent 1, so 1 over 1 is 1, and the tangent of 45 is 1. So if you're lucky and I ask you what's the exact value of tangent of 45, and your calculator tells you it's 1, that's fine. But if you get a decimal, then I will not take that. So you will have to realize you'll have to be able to find the exact value. All right, let's look at cosine. Sine of 30 degrees. So from the 30 degrees, opposite over hypotenuse 1/2, 0.5, 1/2 or 0.5. But exact answer, 1/2. Cosine of 30 is going to be adjacent over hypotenuse. That's root 3/2. That's fine. So that's what I'm going to leave it as. Tangent of 30 is going to be opposite over adjacent. So that's 1/√3. You can't have that. So it's √3/3. Okay. And if I put that in a calculator, second square root of 3 divided by 3 is 0.58. Okay. And that's what the calculator will give you. That's not what I want. Most times I'm going to pay attention to that. And then I just do it from 60. So the sine of 60 is √3/2. That's fine. No radical in the denominator. The cosine is adjacent over opposite. So I'm sorry, adjacent over hypotenuse. And then the tan of 60 is opposite over adjacent, which is √3/1 or just √3. So those are the values that we really want when I'm talking about what are exact values. So even down here, yeah. So just make sure you have to realize you have to be able to label these triangles as well. So you need to know that 1 goes opposite 30, √3 goes opposite 60, and 2 goes opposite the hypotenuse. Okay? All right. See you guys.